vectors. A to B is 2p. That's the M is the midpoint of AB. It's not to scale this, is it? No, it's not. And N is the midpoint of BC. Right, BC, I've got to go from B to C, so I'm going to come back all the way along there and up to there. So that's going to be minus 2p plus 3q. And you should always put a squiggle underneath your vectors. You could write that down as 3q minus 2p, but it shouldn't really matter. A to N, so I've got to go from here, I'll do it in blue, A up to there, to then, so I've got to go A to B, which is 2p, and I've got to go half of B to C. I've just worked out what B to C is, so it's a half of 3q minus 2p. And I need to simplify that. 2p's plus a half, well, it's minus 1p over here. Half of 2p's is 1p. So 2p's minus 1p will be 1p, and then plus half of 3q's is 1.5 q's. And don't forget to squiggle them. What type of what type of quadrilateral? It looks to me as though it could be a trapezium if this bit here is parallel to this one here. If it's parallel, it must be a multiple of q, because that's just got q. So what I need to do is I need to find what m n is. Okay, to go from m to n, I'm going to have to go from m up to b, and then from b to n, and add those. So m to b, it's a midpoint, so that will just be p, plus b to n will be half of what we've just done, of 3q minus 2q, and p, there's a p there, yeah, it's a p, up here it says, half of minus 2p is minus 1p, so p minus 1p is nothing, and so that will be 1.5 q. 1.5 q is therefore parallel to AC, which is 3q, therefore it's a trapezium, and I thought it was, and they've made it hard because there's no way it was M in the centre there. That point there will be more in the centre, and you can see it better that it's going to be a trapezium, but that's question 15 done.